All right, everybody, we're going to get started. Good afternoon. Welcome to the series Mud Talks. My name is Erin McNabb, Associate Director at the Office of Alumni and Parent Relations and a proud member of the class of 2006. I'll be the moderator this evening. We thank you for attending today's event. We hope you and your family are safe during these times. This talk is being recorded and we will distribute the link and any presentation materials afterwards. This event will be pretty conversational and we welcome questions from the audience. Please feel free to type them below in the Q&A box and we'll get through as many questions as we can. Engineering alumni Jonathan Schwartz, class of 2013, and Max Friefeld, 2013, are co-founders of Voodoo Manufacturing, a Brooklyn-based company which operates 2 high-volume 3D printing factories. Since the beginning of the COVID-19 pandemic, Voodoo has repurposed both factories to produce critically needed PPE and medical supplies. Normally, Voodoo produces a variety of end-use plastic parts, including clear aligners for the dental industry. Without further ado, let's welcome Max and John to talk about their business and journey.
Thank you for the intro, Erin, and thank you everyone for attending this talk. We're excited to always reconnect with Mudders, even though we're an East Coast company. We'd love any opportunity to talk with everyone. So yeah, just to maybe quickly give a background on myself and Max and kind of where we went after Mud. So as Erin said, we both graduated from Harvey Mudd in 2013. We were both engineering majors. And actually right out of Mudd, we started our first 3D printing business. It was a purely software company where we made a marketplace for products that people could print on their own printers at home. Ended up working on that for a couple of years and eventually sold that to a company called MakerBot, which actually makes the printers you can see in this photo right now. And so we worked at MakerBot for a little while before leaving to go start our next 3D printing company, Voodoo Manufacturing, which we founded in the spring of 2015. So we actually just turned 5 years old, which is quite exciting. And yeah, at Voodoo, as Erin said, we run 2 separate factories. So this photo, which you see right now, this is in our FDM factory. FDM standing for Fused Deposition Modeling, which is probably the most ubiquitous type of 3D printing. And then our other factory, we actually built 2 years ago to manufacture orthodontic devices, starting specifically with clear orthodontic aligners, which Max is opening up now on his screen. So that's a clear aligner. I'm sure everyone here has seen or heard or had these before, traditionally made by Invisalign, but now becoming a much more common and accessible product. And so we are manufacturing these in our other facility with actually a different type of 3D printing technology, SLA, stereolithography technology, and a number of other steps in the process. And I'll let Erin kind of kick us off with some questions right after this, but about 2 months ago, as the whole pandemic really started to heat up in the United States, we started to think about how we could help, and that's what led us to this point with our effort, which we've called Combating COVID, and as a separate website where we are selling and distributing critically needed PPE and medical devices, starting with face shields and nasal swabs. And so we'll talk about that a lot more.
Great. Can you talk a little bit about specifically this COVID supplies and how you guys have worked to figure out the supply chain logistics and getting them to the hospitals in need?
Sure. I can start. So as John was just saying, about 2 months ago to the day, around March 13th, we initiated a work from home policy at the company for everybody who could work from home, but we're a manufacturing company, right? And so, it's not easy for about half of our staff to do their jobs remotely because they're needed, hands-on, running the printers and producing, parts and equipment that we make. Not only were we concerned about work from home, but, New York was increasingly getting worse in terms of the number of cases and the number of hospital beds that were available at local hospitals was declining. And so it was obvious that in the next week or so, there was going to be a kind of like a universal work from home order. And so for us as a business, there were two things that were really scary about this. One, we were about to be told by the government that we couldn't operate because it was considered unsafe. And so if we can't operate, we can't make any money. And two, we actually have a lot of friends and family and family members at the company who work in the healthcare field and were on the front lines, dealing with this virus. And as you guys all know, New York City, where we're based, ended up being like the epicenter for this in the country, just because I imagine it's such an international place. And so about a week into kind of our work from home, we started to brainstorm ways that we could reapply our factory to help those people that we knew and also keep our doors open for our employees. And the first product that we came to were these protective face shields. One of our employees, Alex, is our model here. And we actually went through a few iterations on the face shield early on. If those of you that follow 3D printing may recognize parts of this design, there's a printer company based in Europe, which again was hit a little bit before the US, that developed an early prototype of this design. We very quickly made about 500 units for a local hospital, Elmhurst Hospital in Queens, and got a few pieces of feedback from them. One, the face shield, in order to be comfortable, has foam and this adjustable elastic strap, and then the clear shields get snapped on the front. And we were sending these unassembled because we just wanted to get stuff out the door as quickly as possible. And they were like, we don't have time for that. You guys need to assemble these because they're just so busy. I mean, it was absolutely nuts. So we learned that, sending a product that didn't have too much effort tied to it so that, healthcare workers on the front lines could get it together quickly and start using it was important. And then there were a few important product features that we had to figure out and improve upon. One is the first design that came from this printer company in Europe didn't have coverage over to the sides of the eyes towards the back of, towards the ears. And so not having side coverage was actually a big problem for a lot of hospitals here in New York. And two, there's an opening at the top to allow your breath to escape so the shield doesn't fog. And we added this like slanted cover for that opening. Again, you're trying to minimize aerolized droplets from getting in because this is protecting your eyes and protecting your face and also keeping your mask clean. So because we're a 3D printing company, we were able to quickly iterate on the 3D printed part of this shield, which is the purple part pictured here. But we also, at the same time, had to spin up this whole supply chain for, and this is a simple product, but for the 3D printed headband, the white elastic that's called buttonhole elastic that has these slots pre-cut into it, right, foam that goes on the inside that keeps it comfortable if you're wearing it for 8 or more hours a day, and then finally, most importantly, the clear shield. And that proved to be its own challenge. It looks like we're getting some questions here, so maybe we can answer those as we go.
Just to kind of hit on...
Nope, go for it, Jonathan.
I was going to say, to hit on a little bit of what Max was talking about when it comes to how we were able to spin this product up very quickly. I think that's probably a topic that everyone has been hearing a lot about. There were a lot of articles, about how 3D printing was kind of one of the unsung heroes, of the pandemic in March. Because what happens, when it started to really get bad in the United States, and across the world, obviously all, existing supply of these types of products was very quickly purchased. And as producers started to even, spin their factories up if they could, there was still just such an overwhelming demand for any of these products. And so really, the supply chain came to a halt in terms of being able to acquire these types of, critical products. And so, what 3D printing is great at, right, is going from, purely just a digital file to a physical part, in just a few hours, right? You don't need to retool a, injection molding press or a larger production line. And so, when we were kind of thinking about how we could participate and how we could help, we were looking at a lot of the different types of PPE and parts that were needed. And really in the first few weeks in March, there was just a lot of noise online, and it was actually quite difficult for us to tell, basically what was needed and then also what we were capable of making. But as Max mentioned, we actually have a number of friends and family who work in hospitals. And so as soon as they started reaching out to us, and as soon as a few articles about this company in Europe, Prusa, who released the first open source design of the face shields came out, then we were able to really latch onto it and start pushing forward with it quickly. And so, I think probably from start to finish, as Max said, we pumped out 500 units in under 2 weeks. And then from there, to date, I think we've made probably between 15,000 and 20,000 units total.
Great. Yeah, someone's asking about how you get your raw materials. Is the supply chain for the raw materials an issue at all?
So we were a little bit early to this, I think, probably because we were based in New York and we got early outreach from a local hospital. The clear plastic shield ended up being probably the hardest part of the supply chain to kind of, one, keep going, and two, like keep sourcing. So very early on, we finalized that face shields were going to be a product we were going to try to make on like a Wednesday. And then by Friday, we picked up some samples of clear plastic. We found the elastic. Also keep in mind, like everyone else, we order stuff on Amazon all the time, and Amazon has like a 2-week lead time at this moment. So we're finding like, we got the elastic from like a fabrics company that makes clothing in the city. And, like we were doing couriers and people were running around getting all this stuff. We found a few plastics companies in Brooklyn that had some of this clear plastic sheeting, and it comes on a big 4x8 sheet, and then you have to stamp it or laser cut it. And so we really quickly, with local suppliers, because speed was so important, spun up a supply chain for elastic, shielding, and foam for the first 500 units. And, in the beginning, it wasn't even clear, like we guessed that this was going to be a product that people needed based on, talking to people we knew. But the scary part about this the whole time is you never know if these hospitals or these people that you're talking to have a massive order that's going to show up next week from China. And so
that was one of the problems early on, which is it was very unclear what actually was happening with the supply chain. Were these companies just waiting on large orders? Was there, literally no inventory anywhere that they could purchase? And, we were struggling to even talk to some of the procurement teams in hospitals. And when we did, even they didn't really know. So, I think we had to take a little bit of a risk of kind of moving forward and purchasing the first large batch of the plastic sheeting and other supplies.
And then, so as we went along, we got through the first run of a few thousand, and then we had to kind of re-up. And so we were gearing up for making, again, like we did, 20,000 units, which, each headband comes with multiple shields. So, we had to acquire on the order of 50 to 75,000 shields. And, we placed an order in mid-March that, fast forward, we didn't end up getting until the end of April. It was just absolutely absurd. So this clear plastic sheeting became like really high in demand. Beyond that, when we got the plastic sheets, the 4x8 sheets, to our die cutters, which were, we had a die cutter in Long Island, we had a die cutter in Queens, and we had a die cutter in New Jersey, because we wanted to like diversify, because at this point companies were closing left and right. 2 out of 3 of those companies actually closed because their employees were getting sick, and they like didn't know what to do. And so this kind of gets to the second part of the challenge, which was for us as a business operating in Brooklyn. Our production team is 10 people, split across 2 factories, and we ended up having enough demand for face shields that we were running 6 days a week, 12 hours a day, or we actually upped it to 18 hours a day at one point. But we split everybody down into teams of 2. And this is something we did like right from the beginning when we did the work from home policy, because we realized if one person gets sick, the official guidance was going to be that everybody who they worked closely with needed to self-quarantine at home for 2 weeks. And so, imagine you have an 8-person production team, they're all in the same room, they're eating lunch together. They're using the same space. You know, if one of them ends up getting sick and gets a positive diagnosis, the entire company shuts down. So we decided to create 2-person teams that would operate in different rooms or at different times, such that if anybody did get sick, we could continue to operate.
Cool. A couple of people are asking about the design, and if it was open source, so you didn't have to license it, correct?
Yeah. So here, I'm sharing my screen. I can go to the company that originated this. So open source design is really common in the 3D printing community because you create a design in 3D. This is their design. You can see ours is a little bit different, right? The shield is wider. We have that coverage on the top. The beauty of 3D printing is that all you need is a 3D file, and this machine will just make it for you, right? And this product does happen to have other components, which adds to the complexity. But the orange pieces in this image, anybody with a 3D printer can make. And so, instead of worrying about, well, who owns the IP on this? We developed this, we want to make money on it. This company and a lot of other companies and individuals in the community can choose to attach an open source license. There's a few different licenses under this thing called Creative Commons. Some licenses don't allow people to make money off of the product, but they can print it for themselves. Some licenses are totally open. Some licenses allow you to modify it and some don't. And so it's just a very helpful, legal infrastructure for sharing digital models. And this company can share it, and they share it with an open source license that kind of limits their liability, right? So nobody's going to sue them if it doesn't work. And so all of these frameworks already existed, and there were 2 or 3 main face shield designs that ended up really, I think, taking hold in the United States and around the world. But I read an estimate somewhere that hundreds of thousands of 3D printed face shields were made over the last 2 months using the open source designs, which is just awesome.
Are there any requirements specifically for medical grade printing or delivering that you guys have had to implement?
That was one of the slightly complex parts of getting started. There are some bodies that list certain requirements for face shields. However, as we started to talk with more and more hospital organizations, we started to realize that they each had their own idea of what a fully effective and safe face shield was. How far around the shield stretched towards your ears, how much head coverage there was, how long it was. Some people thought it should be longer so you had more protection. Others thought that if it was too long, it would hit your chest and therefore it wouldn't be effective. So, at some point after we spoke with a number of people, we just decided on specs that we thought were reasonable and stuck with them. And, that was our product. And we found that it worked for most people we eventually sold to.
Yeah, shockingly, the only standard, there's an ANSI standard for face protection. And for face shields, the only thing it requires is that the plastic is a certain thickness, which is, well, sorry, correct. I stand corrected. It has the thickness, and then there is a portion of the spec that talks about coverage. So our design meets that coverage standard. And then in terms of the plastic material or, top coverage or anything, that's all pretty open. And we found that hospitals had different requirements.
Interesting.
Yeah.
So why do you think the 3D printing market was ripe to help out in the COVID-19 crisis?
Yeah, in some ways, 3D printing has always been a technology in search of a perfect, valuable application. 3D printing is really, it's not just one technology, it's many. And, over the past couple of decades, as it's, evolved, new applications have become unlocked. But still, I think all 3D printing companies are looking for applications, really like high volume end part production applications, where, you know, 3D printing is as valuable as the cost warrants. And, you know, over the past few years, there's been a lot of movement in the 3D printing industry around medical devices and dental devices. If you go look at a company like Carbon or, you know, Labs, that's where they're focused these days. But the other side to 3D printing is, again, the ability to react very quickly and go from 0 to 60 in just a few hours or a few days. You know, the other side of that, which was also relevant for, you know, what we're going through right now, is its ability to be kind of this distributed network of manufacturers. And Max, you know, as he was saying, that to date, I mean, there have been hundreds of thousands of these face shields and many other very important parts and products that have been made by companies and even people all around the globe who have access to 3D printers. So I think it's really proven that it can be this kind of, you know, emergency, you know, supply or part of the supply chain that can kick in very quickly. You know, and the other side of it is its ability to iterate quickly, right? And just our own ability as a company to go from, you know, an initial open source design to a more refined product that meets some of the specs that we were hearing. You know, if we were doing this with injection molding, it would have taken much longer, it would have cost much more money. And actually, we did look into injection molding this product early on, because we were in a couple of conversations where the volumes you were talking about were so high, it just wouldn't have made economical sense for us to make the product. We couldn't have done it in the time period they were looking for the product. So we actually did go and look into injection molding the purple headbands piece, and didn't end up doing it because it didn't quite make sense for us. But, you know, 3D printing, right, it can just kick in very quickly and serve the market. And especially in a scenario like this, where, you know, the supply chain will catch up, right? It's just a matter of when. So, you know, every day that we waited to start shipping product, it was actually less and less valuable.
Cool. We have a quick.
Oh, go ahead.
No, sorry, if you're going to continue.
Well, I noticed there was a question about SLA and FDM. So
That's what I was going to
hit
ask.
on.
Yeah.
Yeah, so we did make other products in addition to shields. Very shortly after we kind of spun up the shield conversation, and what ended up happening with shields is we partnered with USC Keck Medical Center in LA, and they had their own design. So we just made the headbands for them, and they sourced the other stuff, and we made 6,000 units for them. And then we got a large donation from one of the New York Yankees, and they helped us select hospitals like Elmhurst that needed these, and made 5,000 units with that donation and donated them to these hospitals. And so that like kept us really busy once we got up and running. And so there were a few other products that we also made and looked into. One was we did a very short run of 2,000 units in our dental factory, which has a very different set of capabilities. It's actually an FDA registered facility that can make, you know, parts and products that have to be biocompatible. And so we made ventilator parts that are used to connect ventilator hoses. They're actually these very, well, they're somewhat simple hose connectors with valves that you can attach like an oxygen line to, and it basically circulates the air that the patient's breathing out, filters it, adds oxygen, and then puts it back in to their lungs. And they couldn't get these connectors, and all they could do was send us 2 of them, and we literally designed them from scratch and printed them, which is probably its own IP nightmare. But Mount Sinai Hospital really needed these, and we kind of went through some very rapid prototyping and materials testing with them. So we made a few thousand of those units, and that was just a one-off for them. You know, we didn't advertise that product because it wasn't really a product that we were offering in general. And then we also started making these test swabs with our partners at Labs, which is kind of a whole other thing that we're actually still kind of in the middle of.
Yeah, so if face shields were kind of the first wave of you know, highly demanded 3D printed products, nasopharyngeal test swabs are the second. Probably about a month ago, Labs and a few other of the larger 3D printing companies started announcing that they had developed nasopharyngeal test swabs. So these are swabs meant to replace traditional NP swabs that are used in COVID-19 testing. So if anyone here has gone through the unfortunate process of being tested, they take one of these sticks about 6 inches long and stick them up your nose, basically till the tip reaches the back of your nasal cavity, feels like the bottom of your brain, and collect a sample, a specimen of what's back there, and is eventually put into a VTM file and sent to a lab for PCR testing. And due to the high demand for these swabs, the supply chain for them quickly dried up, and a few hospitals in partnership with 3D printing companies started developing 3D printable versions of these swabs. It's actually quite funny because you traditionally think about 3D printing as a great way to produce very high value parts, but not low value parts like these swabs. But because of the kind of size and shape of these, you can actually pack many of them into a single build on a printer. So we print plates that have between 300 and 400 swabs on a single plate. And so our price point, despite not being where the traditional price point of swabs are, which is usually in the $75 to $1 range, whereas our price point is closer to $2, it's still within range of what various health organizations throughout the country could afford. So many 3D printing companies and health organizations started developing their own versions of these 3D printed swabs, and then going through clinical validation, because there was a big question early on of whether or not they'd actually be as effective as traditional flocked NP swabs, what they're called. And that's kind of right around the time when we got involved. As Max was saying, in our clear aligner factory, we use a different type of 3D printing technology, SLA technology. We use Formlabs 3D printers, and so we have a close partnership with them. And they were really the first 3D printing company to develop this product in partnership with University of Southern Florida and Northwell Health. And so, after we started talking to them about this, we received finally clinical validation for the product. Northwell had done and released a study showing that these swabs are as effective, if not actually more effective than traditional swabs. And so we started piecing together plans to go and actually retrofit our aligner factory to produce these, which, we can go into that more, but, it's actually a quite simple product compared to clear aligners. It really only takes a few steps to make them. However, it is an FDA regulated product, medical device. It's a class 1 device, whereas clear aligners are actually a class 2 device because they are meant for long-term use. And so we would still need to jump over many hurdles to bring these to market and actually sell them to customers.
Cool. Someone asks if there are any metrics on what impact you've made with your product, such as an estimate on number of infections avoided. That would sound
definitely not yet.
The estimate. Oh, yeah.
This
How many?
Is the Jay that I know. Thanks,
Yeah.
Jay. That's a hard question. We would love to get feedback from, even on the face shields, the hospitals. It's very difficult to get in touch with some of these people because they're so busy. And I'm sure if they're not just entirely busy, like working around the clock, they're asleep. So even getting feedback, the feedback that we did get was very difficult for the shield. So, the metrics, the rough understandings that I have are that our face shield design is more robust than a lot of disposable ones out there, which are stapled together with foam. And so I think that we probably reduced waste a little bit. I think we allowed people to keep their masks clean for longer and reduce risk that way. But I certainly don't have any numbers around like infections reduced or lives saved by any means. I can tell you that a lot of the hospitals that we deliver these to, their physicians didn't really have much else in the way of face shields when they got them.
And then someone else has asked about if the shields are available for purchase by colleges to aid safe return to campus. And I know a couple places are selling face shields for sure. And I know Harvey Mudd has been gifted a lot of masks for the safe return of students to campus.
Yeah, so face shields are obviously one many parts of PPE, right? There's masks, eye protection is important. So face shields cover that, but you could also wear goggles. You know, if you're in a medical setting, you probably want to wear a gown and, you know, stuff like that. But yeah, so we've already done all the work to spin up the supply chain. We're going to continue to sell these. I think at this point, you can probably buy face shields from China and get them here in like a month if you want to. So that thing we were saying earlier, where like, when is the regular supply chain going to catch up? It's caught up. The fun part is, I think we found that we can make a product at a price point that is still roughly competitive, that has some advantages in terms of durability. And really the whole face coverage design thing that we got, where we were talking to hospitals and improving it, there's a lot of shields out there that don't meet those requirements. So, you know, we think it's a good product. We're going to continue to sell it. But luckily, and this is good for everybody, you can now get them more easily on even on Amazon and stuff like that.
Someone's asked if there's any side effect issues with ramped up production, storage space of raw and finished materials, health protection of workers. You talked about longer hours, air pollution, or handling waste materials.
Yeah, I mean, right now, you know, for us, this has been an all-out effort. Given that, you know, we decided to comply with New York State's restrictions and, you know, halt production of our normal orders. So when this hit, you know, part of this has also been a way for us to, you know, continue to earn revenue as a company and keep our employees, you know, working on things that are relevant and needed. And it's really been great because the whole team has been very driven and motivated by what we're doing now. You know, I think one of the side effects of this, particularly on the sales side of Swabs, has been, it's just, you know, very complex to understand where these are needed and who in an organization you deal with. So we've been talking to some local governments, both in the New York local government and others. So that's been, you know, stressful for us, I think, as a company. In terms of production, you know, we have two factories that are normally making other products. So it's been pretty straightforward to actually go and convert those factories to make these products. Max, can you think of any other side effects?
I mean, the biggest thing was all around the worker safety stuff, which we covered a little bit earlier, which is just like, early on, you know, we implemented this 2-person team. And we also, a few weeks later, put out cleaning guidelines. So between teams, you clean all the surfaces, people wear masks. Some of these things we were already doing in our liner factory, and we just had to kind of enforce them on the FDM factory. And that, I mean, that brought its own challenges, right? Where we had to then we had a few of the N95 masks ourselves, we had them around already as a company for some other things that we make. But sourcing surgical masks and gloves, you know, those were challenges like everything else, but we just tried to provide that for our people. Great.
Someone's asked if there's been any consideration for making the plexiglass boxes that aid doctors in safely doing tracheotomy procedures.
Yeah, I'm familiar with that. I've seen those. We have not talked to anybody who, you know, says that they need those. Not saying that they're not needed. It's just that hasn't been our focus. And since I think the majority of that product is probably laser cut, we could probably build a version. We do stuff like this all the time where we like print, you know, connectors and corner pieces and then buy acrylic and like snap it together. Mm-hmm. But, you know, I think that was a really cool product. I just wasn't under the impression that it needed to be made at higher volume. And it seemed like we weren't the optimal company to make it. There are companies with massive laser cutters and die cutters that could probably just like pump those out really quickly.
What do you think the long-term effects of COVID will be on 3D printing? Kind of the future of 3D printing after this.
We're talking about this stuff right now a lot as a company, so it's a hard question.
It's funny, again, because this has really been an opportunity for 3D printing to shine at what it does best. You know, I think the hope is that, in a crisis, yeah. I think the hope is that, you know, governments around the world and existing manufacturing companies start thinking about 3D printing as more of a complementary manufacturing technology to bring into their existing factory, as opposed to a completely separate and different technology. Right now, most manufacturing companies are either, they choose technology, right? You verticalize around a single technology. But, clearly 3D printing and other digital technologies have their benefits. And so I think that it would make a lot of sense for large, manufacturers to start investing more in including 3D printing into their production process in some way, or using it to even do small runs of products, but much more quickly, essentially what we do. And then also just continuing to see investment in 3D printing technologies from research institutions and governments because of how effective it's been here and the opportunity for it to be effective in other crises where a very quick turnaround is needed. The other side of it is around customized products, which, neither of the products that we're talking about tonight, protective face shields or NT swabs, are customized to a user, but there are a wide variety of products where, you do customize to a specific patient or a specific user. And by being customized, it adds a lot of value and becomes a lot more effective. So clear orthodontic aligners are a perfect example of a product where it's only possible with 3D printing because literally every single unit that we make is unique. And so, I think there are going to be opportunities that come out of this crisis for, new custom products that we didn't, really think about beforehand. So one is obviously masks, like the N95 mask that Alex is wearing, but you could imagine custom 3D printing either the full mask or a specific part of it to make it more effective. N95 masks are actually pretty ineffective unless you really make sure that they fit your face well, and other products that we don't even know of yet.
Great. We have a couple questions. Well, what new interesting thing would you like to create? Fun question.
We create new stuff all the time. I think this process over the last 2 months has solidified to us that 3D printing is a flexible technology, which means it's valuable in a crisis where you don't know what you're going to need and when. For us as a company, it's really solidified our ability to quickly spin up production for new products. And one of our strengths now that we've built this clear aligner facility and focused on some other things is medical products specifically. And so I think there are other medical products that we are eager to kind of look into and launch that can either have an effect or help with the next 12 months of, the world trying to reopen or function and coexist with this virus.
Just to chime in there for a second, when we talk about NT swabs, one of the challenges of making this product is that it is an FDA regulated device. And, you can imagine that the overlap of companies that have the ability to, manufacture a high volume 3D printed product and companies that have the proper, systems in place and registrations in place to manufacture medical devices, those two circles do not necessarily overlap one-to-one. And so we were in a pretty lucky position where, as Max said before, our facility is registered with the FDA. We have what's called a quality management system in place that makes it pretty easy for us to go and add a new device and start manufacturing it. And we understand what it takes to go and register new devices with the FDA and talk to them about it. So we were able to start working on this pretty quickly, whereas a lot of other companies that we have good relationships with, despite having the 3D printing capacity in their factories, did not actually have the kind of the regulatory side of this covered. And so I think that we, Voodoo Manufacturing, are very interested and excited about kind of all of the new opportunities to manufacture medical devices with 3D printing and other digital technologies, because it really combines what we now think are our two strengths as a company.
Great. Kind of switching over a little bit, but do you have any advice for personal printers, people who print at their own house or are trying to help out in any way they can as well?
One of the cool things about 3D printing is we happen to have a factory with hundreds of printers. We can do high volumes, but there are also a lot of people with very similar printers. There are thousands of printers, or tens or hundreds of thousands of printers across the United States. And if everybody can chip in, you can get this collective force that actually does help out as well. So anybody with a 3D printer, I assume, is a little bit in tune with the community, but there's a few websites where you can find designs for 3D printed products. And if you know people who need things, you can probably download those designs from the internet somewhere, print them, and do the same feedback cycle where you make sure it works. One thing to be very cautious about that we took, I think a lot of precaution with, is whether you're making face shields, testing swabs, or masks. One of the reasons we didn't go to masks early on was because we didn't want to produce something that gave anyone a false sense of security if it didn't actually protect them. And so we were very cautious about just downloading designs for N95 type masks off the internet, printing them and making them for people because we didn't want to hurt anyone. And if you don't do the due diligence on a product, you need to be really careful not to promise that it does something it doesn't. So a lot of surgical masks, are one thing, but an N95 mask, which would be recommended in a hospital environment or somewhere where people are known to have the virus, you really have to certify that it meets that requirement if you're going to say that.
Great.
John, any other at-home tips that end up being a little more cautionary than exciting?
Yeah, definitely what you just said. Don't make things and promise things that you can't promise. But I think rather than trying to make your one printer into a factory and make hundreds of these, I would say focus on the people that are close to you, right? If you have a family member or a friend who is on the front lines, who is a healthcare worker, and when we were starting this, we were getting messages from friends who were in hospitals and were being told that they needed to reuse the same face shield again and again and again, or that they needed to find something at home to protect their face. And obviously that's just horrible, right? They shouldn't be scared about going into work every day. So I think focusing on yourself or the people around you rather than trying to turn your printer into a factory is definitely much more helpful and much more manageable. And otherwise, just inventing and playing around with things, despite maybe you not being able to bring an FDA registered product to market, that doesn't mean that you can't take an open source design like this headband, modify it a little bit and put it back online and help people out. And I'm sure there are ways that this headband design of ours could be improved. And I think collectively, the more that people invent, then the better product we're going to end up with.
Great. We've got some questions about Voodoo specifically. When you dreamed of this company, was it at Mud? What does Voodoo come from? Where does the moniker come from? If you want to go into details about that, that'd be great.
So what was the first question? When did we dream this up?
Yeah, this is your second 3D printed company, right? So you start with layer by layer, right?
Yeah, so the origin story of layer by layer, Max and I were supposed to be studying for an E82 chemical engineering test. And we were studying for it. We actually weren't really even great friends. We just happened to sit next to each other in class and talk before and after class. We didn't know each other that well. And
I was going to say, did Max just find out that you weren't his friend at that time? Did you just?
We were not friends. We just didn't hang out outside of class.
Sure.
Yeah, it's funny at a school as small as Mud that you don't have tons of time to really get to know everyone there, but we hadn't had that opportunity. And studying for this test, we were talking about, I think, our summer internships that we had lined up, and talking about other interesting technologies that we were excited about. And this was in 2012, right as MakerBot and desktop 3D printing was becoming very popular. I think Brie Pettis had just been on the Colbert Report, which was kind of one of the big moments for desktop 3D printing when it really gained mainstream attention. And, both of us being engineers, and actually even in high school, both Max and I had access to a 3D printer, amazingly. So, we weren't experts at the time, but we were familiar with it. And, we both thought it was a really neat thing. And so, we were just talking about ideas and came up with this idea for our first company. And, both decided to turn down our internships that summer and try to start a business, which we knew nothing about doing. And actually, Prof. Gary Evans, who I heard just retired recently, was really one of our biggest, mentors and cheerleaders at MUD, and helped teach us how to do, how to start a business and how to go out and build a product and eventually raise money. So yeah, that's kind of the origin story of our first company. And also, we pulled in Oliver Ortlieb, who was a year older than us. So he graduated in 2012 and was a computer science major, to join us in starting the first company.
There really was a common thread between the two companies. We had the first company, we sold it, we worked at another company for a year. We still kind of had some ideas from the first time around, and we were able to kind of leverage that experience. And a lot of our first customers came from the company that originally bought us. And so I just think we've been very motivated and driven and interested in 3D printing. We look for opportunities and we take them when they pop up, and that's kind of just gotten us to where we are now. But it all started at MUD.
Someone wants to know where Voodoo, the name, came from, Voodoo Manufacturing.
We offer mystical manufacturing services.
Oh, okay, got it. And then someone's asking, do companies come with you with ideas, or do you reach out to companies like the cookie cutters I think they saw on your website?
Both, yeah. So we, Voodoo was founded as a contract manufacturing business making products for other people. So they have the ideas, we help them along a little bit, but they're the ones that make the product happen from a sales and marketing perspective. When we started moving into medical devices, we had to focus a little bit more, so we couldn't just make everything. And in these scenarios, we do a little bit more of the outreach, and because we're the FDA registered facility, we're kind of more the product owner. So we do both.
Great. If there's any last minute questions, please type them. Any other final words you guys want to say about Voodoo this time?
Yeah.
If anybody wants to reach out or had questions that they want to email us with, my email is just max@voodoomfg.com. John's is jonathan@voodoomfg.com, and we'd love to talk.
Jonathan, did you want to say something?
Basically going to say the same thing. And, once this hopefully all calms down a little bit, if anyone's ever in Brooklyn and wants to come by and see our factory, we'd love to show you around.
Great. Well, I want to thank our two speakers today for sharing their thoughts on 3D printing and manufacturing. Thanks, Jonathan and Max. I hope everyone enjoyed our talk. Oh, my screen just changed. Where did it go? There we go.
I just turned off the screen share.
Yeah, you messed up everything, but it's okay. I hope everyone enjoyed our talk today. Thanks so much for attending this event. We will distribute the recording and presentation materials in the next few days, including links and email addresses. Next up in the MUD Talk series will be next Thursday. It's about building wealth in 2020 with Bev Orth, class of 1974, and Bruce Barton, class of 1986, giving advice to young professionals and recent graduates about how to set yourself up for financial success. Also, this Sunday, President Maria Clave will offer a special message to the class of 2020 during their senior recognition event. The entire MUD community is invited to join and help celebrate our newest graduate. Finally, I want to offer a word of thanks to those joining in today who have supported the HMC Community Emergency Aid Fund. To date, we've raised just about $267,000 in gifts and pledges that will help us provide assistance to members of our community during these uncertain times. You can find additional information about these items I just mentioned and much more at our online offerings page using the link included in your confirmation email or by visiting alumni.hmc.edu and clicking online offerings. Thanks again for joining us and have a great day. Bye.
Thanks so much, everyone.